Hey guys, I'll be starting a new tutorial for API testing with Postman. Welcome to API testing using Postman session 1. In today's session, I will cover different agenda from the core concept of API testing. So first I will cover what is client, server and host, the client server model and architecture, what are web service and what are the different component of web service, what is HTTP and HTTPS, what is URI and URL and what is the basic difference between them, what is API testing process, how to approach API testing, what are the key benefit of API testing, why API testing is important, and the different type of API testing best practices, different tool associated to API testing, types of bug that API testing detects, and the key challenges of API testing. So what is client, server and host? So first let's concentrate on the client. So what is client? A client is a computer hardware device or software that access a service made available by server. The server is often located on separate physical computer. Then what is server? A server is a physical computer dedicated to run services to serve the need of other computers. Depending on the service that is running, it could be a file server, it can be database server, home media server, print server or other web servers. So if you refer the diagram here, you could see there are so many clients can be connected to a single server, definitely where internet will be required. So each and every client will try to interact with the server and try to get the information or the fetch the information right required from the server. And information means it can be retrieval part, it can be update, it can be delete, any kind of part it can be done to the server, right? So what is host? A host is a computer connected to other computer for which it provides data or services over a network. In theory, every computer connected to a network acts as a host to proceed act as a host to other peer on the network. In essence, a host reflects the logical relationship of two or more computer on a network. Let's say user want to download an image from another computer from his network. So that computer is hosting the image and therefore it is the host computer. So in case you want to download an image, right? So that you can be a client, right? And the host which is having the images from where you want to download it will be termed as host computer. On the other hand, if the same computer downloads an image from other computer, then user computer becomes the host computer. So your computer will become the clients here. So that's why, right, the relationship stand, right? So user computer can be host to other computer. Likewise, user router can be host to other router. But a host must have assigned IP address. Therefore, modem, hub and switches are not considered host because they do not have any assigned IP address, right? So host will always have some assigned IP address, but in case some of the things, right, does not contain any IP address like modem, hubs and switches will not consider as a host. Then what is the client server model? So before that, what is host name and host ID you need to know, right? The host name is nothing but the name of the computer. The host ID is the physical address of that particular computer. What is client server model? The client server model or the client server architecture is a distributed application framework dividing tasks between server and the client, which either reside in the same system or communicated through a computer network or the internet. The client relies on sending a request to another program in order to access a service made available by the server. The server runs one or more programs that share resources with and distribute work among clients. So that is the basic concept of the client server model. So the client server relationship communicates in a request response messaging pattern and must adhere to a common communication protocol which formally defines the role, language and dialog pattern to be used. Client server communication typically adhere to the TCP IP protocol suite. TCP protocol maintains a connection until the client and the server have completed the message exchange. TCP protocol determines the best way to distribute application data into packets that network can deliver, transfer packet to and receive packet from the network, and manage flow control and retransmission of dropped or garbage packet. IP is a connectionless protocol in which each packet traveling through the internet is an independent unit of data unrelated to any other data units. Client requests are organized and prioritized in a scheduling system, which helps server copes in the instance of receiving requests from many distinct clients in short space of time. The client server approach enables any general purpose computer to extend its capability by utilizing the shared resource of other hosts. Popular client server applications include email, the World Wide Web or WWW, and network printing. What is the client server architecture? So in the real time there will be four main category of the client server computing. One is the one tier architecture, second is the two tier architecture, three tier architecture, and the n tier architecture. So in the diagram I already tried to depict three main architecture here. The client server architecture. One is one tier, where you can see the computer or the client or the server will reside in a single single system, right? Whereas two tier architecture, the client tier will be in another one and the database tier will be another one, right? And here in the three tier architecture, three tier will be there. One is the client tier, one is the business logic tier, one is the database tier, right? So with the help of business logic tier, client tier will try to interact the database tier here in the three tier architecture. So let's go one by one. So in one tier architecture is nothing but where the data and application reside in one machine, presentation, business and data access layer within a single software package. The data usually stored in local system or a shared drive. Applications such as MS Office comes under one tier application, right? So you are having MS Office means Excel, right? Word document, PowerPoint, right? But in your system already stored, right? So everything is stored in a single software package. Whereas in the two tier architecture, client reside at one system and database server is another system. User can have multiple clients. For instance, online ticket reservation software use the two tier architecture. The client server GUI is written in high level language such as C++ and Java. So you can see there is a client and there is a database layer. So client can be multiple. Just I have given the example called that online railway or any other ticket reservation, where multiple user will try to interact the database and they will try to fetch the information, they will try to book something, so that will also go to the database tier to save the information as well, right? And whereas three tier architecture, right, user definitely require the internet, right? This is applicable mainly for web application. So we have client browser, then DB browser. Client browser is nothing, right? The client will be interacting. DB browser is nothing, where it will be storing the data. In between client and or DB, right, or the client and server, there is a business logic layer which is called the middle layer. So here it will be three layer, right? So the first one is the database layer of the database server, which is kind of act as a backend where all the data will be stored, and your client layer or the client server or the presentation layer or the UI layer is nothing but the front end from where the client will try to interact with the database. And in the middle there is the application layer or the application server or the web server, which is nothing but all the business logic will be defined, right? So front end and the back end will interact based on the business logic or the business layer, right? The last one is entire architecture, which is nothing but it divides an application into logical layer, which separate responsibility and manage dependency, and physical tiers which run on separate machine, improve scalability and add latency from the additional network communication. Entire architecture can be closed layer in which layers can only communicate to the next layer. In case it is a closed layer, so all the layer cannot communicate, only the layer can communicate to the next layer. But in case of open layer, right, where all the layers, any kind of layer can communicate to the other. So that is the difference between the entire architecture. So where multiple kind of layer will be there, right, in between. So that is the entire architecture. What is web service and what are the component of the web service? A web service or any bit of service that makes is accessible over the internet and normalize its correspondence through XML encoding. A customer consumes web service by sending a solicitation, right, and the service send back an XML response. Web service summons communication over a network with HTTP as the most widely recognized method for network between the two frameworks. So web service is equivalent to SOA, which is nothing but the service oriented architecture, and fundamentally depends on measures, for example XML RPC, and SOAP, which is nothing but the simple object access protocol. Then what are the component of web services? So all the standard web service says work using the following component. One is the SOAP, one is the UDDI, one is the WSDL. So SOAP is nothing but the simple object access protocol. UDDI is nothing but the universal description or discovery and integration, whereas WSDL stand for web services description language. So what is web API? API stands for application programming interface. So it's so web API, it's a collection of communication conventions and subroutines used by various programs to communicate between them. A developer can utilize different API apparatus to make its program simpler and less complex. Likewise, an API encourages the developer with a proficient method to build up their product program. Thus, in simple terms, an API determines how programming segment ought to associate with one another. It is a set of protocol and schedule. It is a and its reaction are returned as with the form of JSON or XML in data. API can utilize any kind of communication convention and are not restricted similarly as web services. What is the key difference between API and the web services? So web services is a collection of open source protocol and standard used for exchanging data between system or application, whereas API is a software interface that allows two applications to interact with each other without any user involvement. So that is the main difference. Apart from that, there are so many other differences there. Web service is used for REST, SOAP and XML RPC for communication, while API is used for any style of communication. Web service supports only HTTP protocol, whereas API support both HTTPS and HTTP protocol. Web service support XML, whereas API support XML and JSON. All web services are API, but all API are not web services. Then what is the basic difference between HTTP and HTTPS, and what are the right importance of them? So if you see the diagram here, right, so if you see the HTTP, so right, the user is interacting, right, to a particular server, right, where they are suppose say they want to access some URL where they are entering some password, right. So in case user entering it, right, so any kind of hackers can see the password without encryption, right. So they will see the exact, so there is such high chances that someone can hack your password. But in case it is HTTPS, right, so in case user interacting to a server and user trying to open a new URL, right, and you want to enter the password, but that password will be encrypted, right, and hacker will not see the exact password whatever the user is getting entered. So that is the main basic difference. So HTTP stand for Hypertext Transfer Protocol. At its most basic, it allows for the communication between different systems. It is most commonly used to transfer data from a web server to a browser in order to allow user to view web pages. It's a protocol that was used for basically all early website, right? But nowadays most of the website has been changed to HTTPS, which is nothing but the hypertext transfer protocol and secure. That is the additional term has been added, which is stand for S, right? So the problem was the regular HTTP protocol is that the information that flows from server to browser is not encrypted, which means it can be easily stolen by anyone, right? Or especially by the hackers. So HTTPS protocol remedy this by using SSL. SSL is nothing but the secure socket layer certificate, right? Which helps create a secure encrypted connection between the server and the browser, thereby protecting potentially sensitive information from being stolen by the hackers as it's transferred between the server and the browser. So what is URI and the URL, right? So URL already see if you can enter something, mostly that kind can be URL, you can access to the browser. So what is URI? URI is nothing but the uniform resource identifier, is a sequence of character that distinguishes one resources from the another. Okay. So what are the different type of URI available? There are primarily two type of URI. What is URNs and the another is the URL, right? So URL is nothing but it's a part of the URI only. So URN is nothing but the uniform resource name, is a persistent and location independent identifier, whereas URL, which stand for uniform resource locator, is a specific type of identification that not only identifies the resources but tells user how to access it or where it is located. The key difference between URI and URL is that URI are identifier, whereas URL are locators. In other words, in a URI simply identifies the resources, it does not describe or imply how to locate the resources, whereas URL does so. So if you go to the diagram here, you could see this is the URL has been given, a complete thing is given, right? Out of which that part is domain, and the second part is the URI, and third part is the square rating. So domain is nothing but the physical server where user website is hosted. URI is the identifier which maps to files on the user server, and the query strings part of GET request to easily pass in values to customer the output. So the most common analogy used to understand the difference between URI and URL is comparing a person name versus their address. So person name is like a URI because it identifies the person without providing any information on how to locate them. So that is the URI, right? So it will giving you the person name information, but not exactly which person is all about, right? So an address, however, identifies the person as it reside of that address and provide the physical location. That is why it's called URL. So that is the basic difference between the URI and the URL. So what is API testing? So nowadays, as of now, we have learned the basic concept, right? What are the URI, what are URL, what is HTTP, what is HTTPS, what is client, server, host, what are the client server architecture. But from now onward, you can learn what is the concept for API testing, what API testing important, how to approach API testing, what are the different tools available, what are the pros and cons of the API testing. So in software application development, API is the middle layer between the presentation layer or the UI layer and the database layer, right, or the backend, right? So it is a layer between the front end and the backend. API enables communicate and data exchange from one software system to another. API testing is a software testing practice that tests the API directly, from their functionality, reliability, performance to security. Part of the integration testing, API testing effectively validates the logic of build architecture within a short span of time. Applications frequently have three layers, right? A data layer and service layer. Both are called API layer, and the presentation layer, which is called nothing but the user interface layer. The business logic of the application guides to how user can interact with the services, functions and data held within the app is in the API layer. So API testing focus on analyzing the business logic as well as the security of the application and data responses. So an API test is generally performed by making requests to one or more API endpoint and comparing the response with the expected result. So API testing is a type of software testing that analyzes an application program interface or API to verify it fulfills its expected functionality, security, performance and reliability. The method are performed either directly on the API or as part of integration testing. An API is a middleware code that enables two software programs to communicate with each other. The code also specifies the way an application requests services from operating system or other application. So API testing is frequently automated and used by DevOps, quality assurance of the QA engineer and the development teams for continuous testing process. Then what is the API testing process, right? For so each and every automation, right, you will be having some sort of steps or process associated. Similarly, for the web service or API testing, right, we have 5 different processes to follow. First thing is that is API specification review. So just like the every other project, right, we need to review our requirements. So here we will review the API specification and use case documentation from the test perspective, right? Then we will go for the test specification development. As and when we have documented the specification, whatever are the different topics, different functionality, we need to automate it, right, with the help of API testing. It can be any tool, right, it can be REST assured, it can be Postman, like that. But the document details is nothing but test specification development. These document details the test condition and the expected result for each and every test case. Then we need to, right, develop some framework. So it is test framework development. So use standard open source tool like SoapUI, JMeter to develop a set of static resources, right? The next four API testing process will be test case development, right? So once you already designed the framework, right, there we need to identify the what are the different API test case need to be automated, right? So we show coding of the test scenario, creating sanity check for test scenario, surveillance test suite, right, validating the precondition assertion, all this stuff we need to do, right, for the test case development. Then the last one is nothing but the test execution and the reporting. So where execution of the developed test suite and the reporting, after that it will generate the result, right, overall result of the API testing. Then we can publish the result to the respective stakeholder, right. In case of failure we can log as a defect in the defect management tool, and then we can interact with the developer that this the part is not working, right. So that's why, right, web service or the API testing process work in the real time. How to approach API testing? So an API testing process should begin with a clearly defined scope of the program as well as a full understanding of how the API is supposed to work. Some questions the tester should consider include what endpoints are available for testing, right? What response code are expected for successful request as well as for unsuccessful request? Which error code is expected to appear in the body of an unsuccessful request? This is the primary 4 thing, right, you tester need to consider. So the next one is the once factors such as these are understood, right, tester can begin applying various testing techniques. Test cases should also be written for the API. These test cases defines the conditions or variable under which test can determine whether a specific system performs correctly and responds appropriately. Once the test cases have been specified, tester can perform them and compare the expected result to the actual result. The test should analyze responses that include reply time, quality of the data, confirmation of the authorization, HTTP status code and the error code. API testing can analyze multiple endpoints such as web services, database and the web user interfaces. Testers should watch for failure or unexpected input. Response type should be written and acceptable agreed upon limit, and the API should be secured against potential attacks. Tests should also be constructed to ensure user cannot affect the application in an unexpected way, that the API can handle the expected user load, and that the API can work across multiple browser and services. The test should also analyze the result of non-functional test as well, including performance and security. What are the benefit of the API testing? So major benefit I show that, so I told you that whenever like there is some development work is going on and no API no UI has been designed as of now, but API testing can be performed, right, for that one, because it will interact between the UI layer and the your database layer, right? So it will be having so many different logic will be there, and based on the logic it will interact, right? But in case your UI is not ready, so you can still perform the API testing, right, where you can get the different responses for different input and you can validate it accordingly. So in the real time, right, just before the testing should perform on the UI level, you can discover so many defects, right? So what are the different benefits of the API testing? Early testing. With API testing, once the logic is designed, test can be built to validate the correctness of responses and data. We do not have to wait for various teams to finish their work or for full application to be inbuilt. Test cases are isolated and ready to build immediately. User test maintenance. UI are constantly changing and moving around based on how they are accessed. Browsers, devices, screen orientation, etc. This creates a nightmare scenario where tests are being constantly rewritten to keep up with the actual code in production. API changes are much more controlled and infrequent. Often API definition files like OpenAPI spec can help refactoring test only a second of work, right? So faster time for resolution. When API test fail, right, user know exactly where their system broke and where the defect can be found. This helps reduce time triaging bug between the builds, integration, and even other team member. The small isolated footprint of any API test is perfect for faster MTTR status, a valuable KPI, and the DevOps team. The next benefit is the speed and coverage of testing. So 3UI UI test might take 30 hours to run. So in case you want to validate some scenario at the UI level, it might take like 40 minutes to 1 hour time to execute a particular scenario. So suppose say in case of 3000 UI test you need to do, and 3000 API test could be run in 3 minutes, whereas 3000 right UI test might take 30 to 40 minutes. So that means user will find more bugs in less time while also being about to fix them immediately. Knowledge independent. Data is exchanged via XML and JSON format only in the API testing. So any language can be used for test automation. XML and JSON are typically structured data, making the verification fast and stable. There are also built-in library to support companies' data using this data format. The next one is kind of the GUI independent. So API testing can be performed in the app prior to GUI testing. So early testing means early feedback and better team productivity, right? The app's core functionality can be used to ensure can be tested to expose small error and to validate the build strength. The last important benefit of the API testing is the improved test coverage. So most API or the web service have specification allowing user to create automated tests with high coverage, including functional testing and the non-functional testing. Then the how to approach API testing. So an API testing process should begin with a clearly defined scope of the program as well as a full understanding of how the API is supposed to work. Some questions that testers should consider include: what endpoint is available for testing, what response code are expected for the unsuccessful error, what response code are expected for successful error, which error message is expected to appear in the body of an unsuccessful request. So these are the different thing, right, tester should consider always. Okay, so once factors such as these are understood, so tester can begin applying various testing technique. The cases should also be written for the API. These test cases define the condition or variable under which test can determine whether a specific system performs correctly and responds appropriately. Once the test cases have been specified, tester can perform them and compare the expected result to the actual result. The test should analyze responses that include HTTP time, data quality, confirmation of the authorization, HTTP address code, and the error code. API testing can analyze multiple endpoints such as web services, database, or web user interface. Tester should watch for failure or unexpected input. Response time should be within an acceptable agreed upon time limit, and the API should be secured against potential attack. Tests should also be constructed to ensure user cannot affect the application in unexpected way, right? That the API can handle the expected user load, and that the API can work across multiple browsers and the devices. The last approach is the test should also analyze the result of non-functional test as well, including the performance and the security. What are the benefit of the API testing, right? So there are a lot of benefits there in the API testing. That is the reason API testing is very important tool in the market, right? API testing very useful. There are so many tools like Postman, REST assured, right? There are so many tools I'll discuss in the next slide. Okay, so what is the benefit of the API testing? First is earlier testing. So with API testing, once the logic is designed, right, test can be built to validate the correctness in response and data. You don't have to wait for various teams to finish their work or for full application to be built. Test cases are isolated and ready to build immediately. Then the easier test maintenance, right? So majority of the test project fails where you have already developed your code, you've already built a framework, but you are not maintaining it properly. Sometimes maintenance cannot happen due to the huge maintenance time. But in API testing, the maintenance is quite easy. So you are constantly changing and moving around based on how they access browser, devices, skin orientation, etc. This create a nightmare scenario where tests are being constantly rewritten to keep up with the actual code in production. API changes are much more controlled and infrequent. Often API definition like files like OpenAPI spec can help make refactoring test only a second of work. Then the faster time to resolution. When API tests fail, user know exactly where their system broke and where the defect can be found. This helps reduce time triaging bug between the builds, integration, and even different team members. The small isolated footprint of an API test is perfect for faster MTTR status, a valuable KPI for DevOps team. Then the speed and the coverage of testing. So sometime API testing will be very fast, right? So in case you want to run, suppose say 300 API UI testing, right? It might take 30 hours to run, but 300 API test could be run in few minutes. That means user will find more bugs in less time, while also being about to fix them immediately. Language independent, right? Then data is exchanged by XML and JSON format, so any language can be used for test automation. XML and JSON are typically structured data, making the verification fast and stable. There are also built-in libraries to support comparing data using this data format. Then GUI independent. API testing can be performed in the app prior to GUI testing. Early testing means early feedback and better team productivity. The app's core functionality can be tested to expose small error and to evaluate the build strength. Improved test coverage. Most API of the web service have specification allowing user to create automated tests with high coverage, including functional testing and the non-functional testing. The next one is the why API testing is important nowadays. So user interfaces tests are often inefficient for validating API service functionality and often do not cover all the necessary aspects for the backend testing. This can result in bugs left within the server or unit level. A costly, which is very costly mistake that can greatly delay the product release and often requires large amount of code to be written to fix them, right? So API testing allows developer to start testing early in development cycle before the UI is ready. Any request that does not produce the appropriate value at the server layer will not display it on the UI layer. This enables developer to kill at least half of the existing bugs before they become more serious problem. It also enables tester to make requests that might not be possible through the UI, a necessity for exposing security flaws. Many companies are using microservices for their software application because they allow software to be deployed more efficiently. If one area of the apps is being updated, the other area can continue functioning without interruption. Each application section has a separate data store and different command for interacting with the data store. Most microservices use APIs, therefore, as more business adopt the use of microservices, API testing will become increasingly necessary to ensure all parts are working correctly. API testing is also integral to agile software development, in which instant feedback is necessary to the process flow. In agile environments, unit tests and API tests are preferred over graphical user interface or the GUI tests because they are easy to maintain and more efficient. GUI tests often require instant reworking if they want to keep pace with the frequent changes in agile environment. Overall, incorporating API tests into the test-driven development process can benefit engineering and development team across the entire development life cycle. These benefits are the passed along to customer in the form of input services and better quality product. So that is the different important point I have tried to depict it here for the API testing importance. Then what are the type of API testings we should perform generally? API testing typically involves the following practices. For first one, unit testing, right? Testing the functionality of the individual operation, it might be done by the development team. Validation testing, it occurs among the final steps and plays an essential role in the development process. It verifies the aspects of product behavior and the efficiency. In other words, validation testing can be seen as an assurance of current development. UI testing, it is defined as a test of the user interface for the API and other integral part. UI testing focuses more on the interface which ties into the API rather than the API itself, testing itself. Although UI testing is not a application specific test of API in terms of data code base, this techniques still provides an overview of the health, usability, and the efficiency of the application front and the backends. The functional testing, testing the functionality of broader scenarios, often using unit test as building block for end-to-end test. Includes test case definition, execution, validation, and regression testing. The load testing, validating functionality and the performance under load, right? Often by reusing functional test case. Runtime error detection, monitoring and accepts application that execution of automated or manual tests to expose problems such as race conditions, exception, and resources leaks. Then the next one is security testing, which includes penetration testing and file testing as well, validating authentication, encryption, and access control. The next one is web UI testing, performed as part of end-to-end integration test that also requires API enable team to validate GUI items in the context of larger transactions. Then the interoperability testing, SOAP only, which is nothing but the checking conformance to web services interoperability profiles. Penetration testing, consider the second test in the automation process. In this type, user with limited API knowledge will try to access the threat vector from an outside perspective. What is about functions, resource, processes, or M to the entire API is component. Then the fudge testing, last one testing type of the API testing is fudge testing. So massive amount of the purely random data, sometimes referred to as noise or the fuzz. So it is nothing, is a functionality input into the system in order to attempt force cache, overflow, or other negative behavior. This is done to test the API as it absolutely limit and serves somehow as a worst case scenario. Then the why are the what are the different API testing best practices available? So API test cases should be grouped by test category. On the top of each test, users should include the declaration of the API being called. Parameter section should be explicitly mentioned in the test case itself. Prioritize API functions call so that it will be easy for tester to test. Each test case should be a self-contained and independent from dependencies as possible. Avoid test chaining in test script development. Right? Special care must be taken while handling one-time call function like delete, close window, etc. Call sequence should be performed as well planned to ensure complete test coverage. Right? Create API test cases for all possible input combination of the API. What are the API testing tools available in the market? So when performing an API testing, developer can either write their own framework or choose from a variety of ready-to-use API tools. Designing an API test from framework enables developer to customize the test. They are not limited to the capability for a specific tool and its plugin. Tester can add whichever library they consider appropriate for their chosen coding platform, build unique and convenient reporting standard, and incorporate complicated logic into the test. However, testers need sophisticated coding skill if they choose to design by their own. Conversely, API testing tools provide user-friendly interface with minimal coding requirement that enables less experienced developer to feasibility deploy the test. Unfortunately, the tools are often designed to analyze general API issues and problems more specific to testers API can go unnoticed. A large variety of the API testing tool is available, ranging from the paid subscription tool to open and source offering Some specific example of the API testing tool includes SOAP UI, right? Apache JMeter, API, REST Assured, Postman, Catalan, Swagger, etc. So SOAP UI, the tool focuses on the testing API functionality in SOAP and the REST API and the web services. Apache JMeter, an open source tool for load and functional API testing. API, a cloud API testing tool from Google that focuses on API performance testing. REST Assured is an open source Java specific language that facilitates and easy the testing of REST API. Then Postman, a Google Chrome app used for verifying and automating API services. Catalan, an open source application that helps with UI automated testing. Swagger, an open source tool that creates a web page that document API testing. What type of bug that API testing can detect, right? So with the help of normal UI testing we can find out, and in case anything is not working, right, any kind of variation of the data we can pass. So similarly, these are the different type of bugs that API testing can detect easily. Fails to handle error condition gracefully, unused flags, missing or duplicate functionality, reliability issue, difficulty in connecting and getting a response from API, security business, multi-threading issues, performance issue, API response time is very high, improper errors, warning to a caller, incorrect handling of valid arguments, show values, or response data is not structured correctly JSON or the XML. So these are the different type of bug API testing can detect easily from your application. So challenges of API testing. As of now, we have learned what is API testing all about, what are the different tools, different programming language, and what are the other challenges, right? Sorry, what are the other benefit is available for that tool. But for each and every tool, right, there should be some challenges associated, right? So that is the reason nowadays, in case you want to do the API testing with Postman, because of some challenges, other tool came into the market called REST Assured. In case other tool will be coming to handle all the challenges. So main challenges in a web API testing is a parameter combination, parameter selection, and call sequence. So there is no GUI available to test the application, which makes difficult to give input values. Validating and verifying the output in a different system is little difficult for tester. Parameter selection and categorization is required to be known to the tester. Exception handling function need to be tested, and coding knowledge is necessary for the tester. In case if you want to do both the API testing with Postman or REST Assured, right, you need to know knowledge of different framework like Maven, it can be TestNG and relevant programming knowledge, so you can easily solve the API testing challenges. So these are the real-time challenges is already listed out in the API testing. So that's the different topics I have tried to cover as part of the API testing concept. From next session onward, right, I will try to create the videos for the Postman installation, different thing we can do with the Postman, all this stuff. Thank you.